in the UK and JERA in Japan. Uh, we have 17 offices globally. Uh,
James, you're on mute.
sorry about that. So we have a team of 700 researchers, engineers, and project managers all working on offshore wind projects globally. As I mentioned before, we're a 50-50 joint venture between JERA and BP, and we have a portfolio of 13 gigawatts net that we're looking to develop over the next decade or so. In terms of how we undertake these activities, we have a lot of resources and capability to take forward these projects. We have a core strength in project development with a team combining safety and first mover advantage offshore wind projects globally. We undertake the full EPCI end-to-end contract for developing these offshore wind farms, and we look to develop selective partnerships globally with a range of different supply chain operators and technology providers to support us in that goal. And finally, we undertake procurement of innovative solutions which can support our goals in terms of making our projects the most cost competitive that they can be. Just to give an overview of our current portfolio, as I mentioned, we are targeting a portfolio of 13 gigawatts of net potential generating capacity. That's 22 projects across 9 countries that you can hopefully see on the screen. We have quite a few operational projects. The ones with number one against them, you can see are operating wind farms. So we have operating assets in the UK, Belgium, Germany, Japan, and Taiwan. The number twos are our development pipeline. So we have actively development works with 7.5 gigawatts of wind farms. And the remaining are secured longer term development project leases, the 4.5 gigawatts, the number three. So you can see it's a fairly global spread of activity. In terms of this challenge and why we got involved, so I sit within the research and innovation team. We maintain a strong global approach to research and innovation, and we undertake, as you can see on the screen, the scanning of new novel technologies which can support our portfolio, validation and verification of those technologies, and manage research partnerships with companies, research and technology organizations, and universities to support that. We also work to demonstrate and deploy different technologies. So you can see the standard TRL scale at the bottom of the screen, and we'll work with a range of companies across that different TRL range. In terms of our particular challenge for this competition, we're interested in optimizing lifetime extension and asset integrity. As I mentioned, a lot of wind farms these days are looking to have a design life of beyond 25 years, moving to 35 years or even 40 years plus. So optimizing infrastructure design for an extended lifespan is pretty important to us because it extends the operational durability and obviously increases profitability. So new technologies to extend the fatigue life, reduce corrosion impacts, and improve understanding of operational performance are pretty key to some of our innovation challenge areas. We're currently engaged in multiple joint industry programs to support this and work with a range of research organizations in Europe and more globally to address these challenges. To talk in a little bit more detail about the Open Innovation Challenge. So, as I mentioned, we're looking at lifetime extension technologies, and those can fall under a couple of different focus areas. They can be inspection and identification, so early detection of faults and failure modes, and the remaining useful life estimation to enable better risk-based maintenance inspection, and also within maintenance and repair. So more proactive interventions to slow degradation, for example, using robotics or advanced materials or autonomous systems for repair. So broadly, those two categories are challenge areas of interest. What we would like applicants to show is a measurable improvement in the lifetime of the asset or the inspection efficiency versus current state of the art. Applicants should demonstrate the remaining useful life prediction capability that supports optimized maintenance scheduling and reduces unplanned downtime. And these solutions should be quantified through key performance indicators, such as a reduction in inspection frequency, extending operational lifetime, and an increase in asset uptime. We are looking for technologies to get to TRL 7, probably within an 18-month time frame. Not interested in low TRL 1 to 3 technologies that might take too long to mature. And in addition, for successful applicants coming out of the challenge, we would look to work in the forthcoming UK-Singapore collaborative R&D proposal between both countries to help facilitate further research into a topic if we thought there was some of interest coming forward that matched our criteria. So I hope that's been a useful overview of our challenge. That brings me to the end of my slot. Happy to take any questions. So I'll stop sharing now.
Thank you, James. So to everybody in this room, if you've got any questions for James, please type that into the chat box. You can find the icon at the bottom navigation bar. Just wait a moment for you to type the questions in. Whilst we're waiting, James, where do you see, if I could just chip in the questions, where do you see the biggest opportunity for improvement?
Yeah, I think, well, in terms of various opportunities around improving inspection technology, so we understand the rate of degradation at an earlier stage, and we're able to do better planned maintenance and scheduling. Opportunities around preventative measures to reduce fatigue modes that could lead to early repair situations and thereby extending the lifetime of the wind farm infrastructure. So probably in those areas, Derek.
Okay, thank you. Folks, if you got questions for James, please type that into the chat box. We'll just give a moment for people to type. Whilst we're waiting, by the way, don't worry if you missed the opportunity to ask a question, because either because we have to move on or you thought of the questions afterwards. You can always email us. I'll flash the email address at the end of this breakout room. We've got a couple of questions, James. Where do you see the biggest gap between what operators currently do in inspections?
Well, normally you have risk-based inspection as standard for a lot of wind farms. So I wouldn't say there's necessarily a gap. They do a lot of inspection already. I guess it's improving the detection technology out there at the moment. So it's more accurate and maintenance schedules can be planned more readily.
And from Raphael, do you have a focus on inspecting underwater areas in splash zones or aerial areas?
Yeah, so the challenge is quite broad. We are happy to look at inspection of the wind turbine or the foundation substructure or transmission assets. Obviously, all of those can have failure modes that impact on lifetime extension. So, cable failure, there's obviously inspection for corrosion in substructures and the wind turbine themselves and blades and other subcomponents. So yeah, basically the challenge is quite broad because we'd like to develop tools that address all of those issues.
Okay, next question is predictive maintenance of the wind turbine a topic of interest?
Yes, I mean, most wind turbine OEMs will give you a service level agreement for a number of years, but then ultimately the operation of the assets will fall back to the developer. So yeah, wind turbine is also of interest.
Next question, what are the main pain points to identify faults in wind farms for you?
Yeah, I think I've sort of just alluded to, if there's potential failure modes in transmission, cable infrastructure, degradation there, substructure fatigue or scour or corrosion, and then any kind of failure modes with the wind turbine asset as well.
Let's quickly move on. James from Empire Energy just follow up with another question for you. TRL7 as 18-month target, what kind of testing environment or access to assets could you make available to accelerate that maturity?
I think for any applicant, we would ask the applicant to come up with a technology qualification plan as to how they would approach that. I guess there's various research centres out there. I mean, I know Claire's speaking later, or Catapult have operational assets that are used for test research and things like that. So I would say it's more down to the applicant to suggest their technology qualification pathways.
Okay, all right. Let's quickly move on. Can we focus on the particular part of the wind turbine in terms of predictive maintenance, for example, gearbox or main bearing?
Yes, I guess the Open Innovation Challenge is quite broad in that respect. So we're expecting the applicants to come forward saying where they think some of the higher failure modes are and how their technology can prevent that.
Okay. Next question, and I think maybe we'll make this the last question so we can move on. Can I ask how you carry out subsea inspections currently, and what's the main pain point of that?
Yeah, I think I might have alluded to this in an earlier answer, but yeah, there's obviously subsea inspection of substructures, looking at the condition of the asset during its lifetime, using ROVs or other sort of underwater technologies. So really, it's understanding how to optimize that in terms of cost and understanding the analysis of the results that come from that.
Okay, thank you. And just one more question from Craig, and I'll just draw a line there. And all those any additional questions from the floor, just send us the emails and we'll try to get those answered separately so that we can actually move on here. Just one final question here. How much historical data do you have for the training of the AI models? Does this include sensor data, maintenance, and operational records?
Yeah, I think we obviously have operational data from some of our wind farms. I think if the applicant to the challenge was wanting to use some of that, then obviously we'd have to review what they were after and, kind of confidentiality requirements around that. So that I guess we'd have to understand a little bit more the scope of what they were asking.